Hi friends, this is Sarvajan here. Welcome to my networking channel. Hope all are doing good and safe. And today I'm going to show the EIGRP tables. So EIGRP maintain three different tables. One is a topology table, routing table, and a neighbor table. So first let us configure the routing, enable the routing on all these four routers. Then live I'm going to show the different tables and what are the contents inside the table. So, and also I'm going to show how the EIGRP selects the best path algorithm, right? So before that, let us go to the individual configuration. I'm going to configure with the shotgun approach. So what we can do, go to router EIGRP 100 and let us simply define the statement network 0.0.0.0. Similar way, go to auto. This we call it as shotgun approach. Go to configuration mode, router EIGRP 100 and the network is 0.0.0.0. Go to R4 configuration mode, router EIGRP 100 and the network statement is 0.0.0.0 and go to R3 router EIGRP 100 and the network is 0.0.0.0. So like this I have configured so that all the neighbor relationship will come up. This is a shotgun, we call it a shotgun approach. So I defined all the network statements. So this router I defined three different networks, right? 192.168.1.0, 2.0 and 3.0. So similarly R2 has two networks and R3 has three networks and R4 has two networks, right? So for R1 for reaching this, here I have defined a loopback address. So for R1 for reaching this network, there are three paths. One, the first path is R1 to R2, R2 to R3, and second one is R1 to R3, and third path is R1 to R4, R4 to R3, right? So let us see how it selects the best path algorithm. So now let us go to R1 and let us check the show IP EIGRP neighbor. So let us now check the neighbor table. So it already established a neighbor relationship, right? And let us check the topology table. Okay. So now let us go to the configuration. Now let us go to R1. I am going to show about the neighbor table. So this is a neighbor table and what are the contents inside the neighbor table. First it identify the address, right? So what is the neighbor address and the interface through which the neighbor reached, and hold down timer is nothing but I already told is the amount of time it wait before declaring the neighbor dead. That is a hold down timer. So uptime is nothing but how long the neighbor is up. That we call it as an uptime. And SRTT is nothing but a smooth round trip timer. That means the number of packets sent to the neighbor and getting the acknowledgement back from the same neighbor, what we called as a SRTT, smooth round trip timer. That means a packet sent to the neighbor and receiving the acknowledgement. So what we called as a SRTT. And RTO is nothing but a retransmission timeout. That means retransmitting a packet again from the queue to the neighbor. So what we called as a retransmission timeout. And this is the queue count and the sequence number for each and every neighbor, right? So this is the neighbor table. So it identifies the neighbor address and the interface through which the neighbor is learned, right? So what we call it as a EIGRP neighbor. So EIGRP dynamically discovers all the neighbors and it will maintain in the EIGRP neighbor table, right? So the next thing what I'm going to show about, let us discuss about the EIGRP topology table. So go to the show IP EIGRP topology table. So topology table contains P. What is P is nothing but a passive. So passive state is nothing but the route status is good, right? That means it is not undergoing any recomputation. That means it already identified all the networks and it maintained this table, routing table, right? Topology table. So passive is nothing but the routing status is good. That means it is really good. And active means nothing but it is actively searching for the route, right? But passive is already searched the route, already found the route, and it maintained the topology table. So that status we call it as a passive status. And topology table we'll see two things. One is a successor and the feasible successor. So what is successor is? Successor is always the best route in the routing table, and feasible successor is a backup route. And FD is nothing but a feasible distance. So now let us go see that. So let us see this network 192.168.5.0. This is a network, right? So for reaching 5.0 network, this is the destination network. It has one successor and FD is nothing but a feasible distance. So what is FD and the advertised distance AD? Here this we call it as an FD divided by AD. So what is an advertised distance or a reported distance? So the metric reported by the neighbor we call it as a reported distance or the advertised distance. and the total distance from R1 to R2 to R2 to R3, we call this as the total distance or the feasible distance. So always the least feasible distance is calculated and it will be maintained in the routing table. But topology table will show all the three paths, right? It will show all the possible three paths from R1 to R3. So there are three paths, R1 to R2 to R3, then R1 to R3, then again R1 to R4, R4 to R3, right? So there are totally three paths it is reaching, 1.2, 3.2 and 2.2, right? So you're able to see 1.2 and the second is 3.2 and the third is 2.2. So three paths it is showing for reaching this destination network. So always it should show FD by AD. FD is the feasible distance. This is the least distance, feasible distance. AD is the reported distance. So it will learn all the feasible distance and the reported distance for all the destination network, right? So that is the content we'll see in the topology table. So now let us see the routing table. So go to R1 and check the show IP route. So let us see what is the route it has learned. So always keep it in mind, it will always learn the best route, right? So as per this topology table, for this reaching this destination network 5.0, so there are three paths, right? You are able to see three paths, but the least feasible distance, right? Least total feasible distance is 309760. So compared to these two feasible distance, always the lowest feasible distance will be installed in the network. That means always this distance will be show up in the routing table. So it always learn the path via 1.2 with the least feasible distance, right? So you can see. So the 5.0 network, it is installed the least feasible distance. So this is nothing but a administrative distance. This is not an AD, we call it as an administrative distance divided by the feasible distance. That is the least feasible distance. It will always install in the EIGRP routing table, right? So what about this thing? Second path is what we called as a feasible successor. So feasible successor condition is the next top router, that AD. This is the AD, right? So this AD should be less than the FD of the current successor. So FD is the 309760. So this AD should be less than the FD of the current successor. That is a feasibility condition. So for becoming a feasible successor, it should be less than the FD of the current successor, right? So then this is selected as a feasible successor. So this is a destination network. It has one successor and a feasible successor. So what is feasible successor? In case when a primary route or a successor goes down, so when this goes down, right, when this network goes down, automatically the feasible successor will be moved from topology table to the routing table. So let us see how it is selecting. So now let us go to the R1 and let us shut down this network, right? Let us shut down this interface, fast Ethernet 1 by 1, this 0 by 1, right? That is a route it has already learned, 1.2 it has learned, right? This interface is fast Ethernet 0 by 1. So let us shut down this route, shut down this interface and let us check the topology and the routing table, right? I already told this is a feasible successor. So this should be moved from the topology to the routing table. You should see 3.2 here for the 5 network. So now let us go to the configuration mode and I'm going to shut down this interface. Interface fast Ethernet 0 by 1. Let us shut down this. So now let us see the topology changes. So go to show IP EIGRP topology. So now let us go to EIGRP topology, right? So for the 5.0 network, it installed this as a successor. You're able to see. So previously I shown 1.2 is a successor, right? So since 1. Network is down, automatically this will become the successor. That is, previously it was a feasible successor. Then automatically this feasible successor will be installed in the routing table. So let us go to R1 and check the show IP route. So for the 5.0 network, it installed the next successor. That is a feasible successor is nothing but a backup route. So when the primary route is down, it will install the feasible successor as successor in the topology table, and automatically this feasible successor will be installed as the best route in the routing table. So this is a routing table. So these are the three tables we have to always keep it in mind. One is the topology table, neighbor table, and the routing table. So the neighbor table contain information like neighbor address and the interface through which neighbor is learned, and it will show the uptime and the hold down timer of the neighbor, right? And the second is the topology table. Topology table will inform the whether the network is passive or active, and it always shows the advertised distance. That's the reported distance, plus also it will show the total feasible distance. So all this information will be contained in the topology table, and the routing table always contains the best route, right? Best route with the least feasible distance. So these are the key points you have to remember about EIGRP table. I hope you understand this. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.